Hello everyone. In this lecture I shall discuss the basic concepts and solution of partial differential equations. Now if you recall an ordinary differential equation, in short we write ODEs, ordinary differential equations, right? What happens? We have a function y of x say, or if we think of the applied ODE, it is y of t is a time, right? So here y is the single dependent variable and x is the single independent variable, right? So the thing is that it involves one dependent variable, and one independent variable, right? You see, one independent variable and one dependent variable, and the differential coefficients or the derivative terms or the differentials, right, of the dependent variable with respect to independent variable. There may be one such derivative term or more than one derivative terms, no issue. For example, we have dy by dx is equal to 0, right? This is an ordinary differential equations. X dy plus y dx is equal to 0. It involves the differentials, right? D square y by dx square plus 5 dy by dx plus 6y is equal to x square plus 5, right? X square plus 5. You see, in the right hand side we have x square plus 5 here. So it is a non-homogeneous category and this is a homogeneous category, right? So now what is a partial differential equations? Just a simple extension of this ordinary differential equations. We can write like this. Now if you compare this definition with PDEs, then what will happen? An equation involving several, these derivatives will be partial derivatives, right? If we think of from the viewpoint of PDEs, right? From the viewpoint of PDEs, then what will happen? Instead of derivative, we will write partial derivatives of an unknown functions, right? Of an unknown function. Of an unknown function the same. Of one dependent variable. One is that one, okay? One is that one dependent variable. And this one will be replaced by two or more independent variable, right? And here y of x may be viewed as u of xy, or it may be u of xt, or it may be here u of xyz. So you see, here we have more than one independent variable, but the dependent variable is only one, right? The dependent variable is only one. So this is the difference between ordinary and partial differential equation. Very small change. One dependent variable in both the cases, two or more independent variable, right? And it involves the partial derivatives of the dependent variable with respect to the independent variables, right? So we can write the definition of a PDE as follows. An equation, if you want to write the definition of PDE, is what you can write? We can write an equation involving one or more partial derivatives, right? One or more partial derivatives of an unknown function of one dependent variable, right? And we have two or more, right? So here we use the word partial derivatives. Here we use two or more, right? Two or more independent variable, which are usually of the form here what u xy or zxy, or we have uxt. So t is for a time, or you can write u xy z, whatever it may be. Here it involves three independent variable. It involves two independent variable, one being the time. So in applied PDE, we'll consider this in applied PDE. There must be a time variable here, right? For applied PDE. Applied PDE, we have a time factor here, okay, t. Clear? For example, if we write for example from the viewpoint of, suppose my uxy, from the viewpoint of my uxy, right, uxy, I can write here uxx plus uxy is equal to 0, or simply I write ux is equal to 0. This is also a PDE. It involves one partial derivative term. It involves two partial derivative terms. Or if I write uxx plus 2uxy plus uyy is equal to some x plus y plus u. This is also a PDE, right? So it involves one or more partial derivatives of a single dependent variable u with respect to two or more independent variables, right? So this is what the definition of a PDE. Now we will discuss some standard PDE such as the one-dimensional wave equation, two-dimensional wave equation, one-dimensional heat equation. This thing we will discuss. Before the details of my discussion, let me to introduce myself. Professor Kumar Paikray, S.K. Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay. At this stage also, my appeal to all of you is that please like and subscribe to this channel, which will boost my motivation to upload the subsequent lectures for your benefits. At the same time, whatever the new lecture will be uploaded, it will come to your screen. Also, don't forget to share this lecture with your friends so that they will also benefit. Okay. So let me to discuss the details of the PDEs. If I consider z as a function of two independent variables xy, then some standard PDEs, if I write what is your zx means del z by del x, and we denote it by p. Then what is your zy? Zy is your del z by del y, we call it q. Then here zxx, what is here zxx means partial derivative of z with respect to x twice, del square z by del x square. Okay, we denote it as r. Then zxy, so this will be del square z by del x del y, we denote it as s. Then coming to here zyy, so this is equal to del square z by del y square, we call it as t. So these are some standard notation, p, q, r, s, t, right? So for usual PDEs we use these terms, but my concern here is to discuss the applied PDEs. Okay, my concern here is to discuss the applied PDEs. For which I write some partial differential equations such as one-dimensional wave equation. Suppose I write one-dimensional wave equation. We have one-dimensional wave equation is u t is equal to c square u xx. right? UTT means that means what? Del square u by del t square is c square u del square u by del x square, right? In short, I write like this. Similarly, one dimensional heat equation will be ut is equal to c square uxx. Then two dimensional Laplace equation will be uxx plus uyy is equal to 0. Then two dimensional Poisson equation is uxx plus uyy is f of xy, right? So then two dimensional wave equation will be, just you see, two dimensional wave equation, right? So it was one dimensional. Now for two dimensional it will be, you see, utt will be c square uxx plus uyy. You see the difference, it is c square uxx, so it is c square uxx plus uyy. Then likewise here two dimensional heat equation will be, you see, just an extension of this, right? Just an extension of this. It will be ut is equal to c square uxx plus uyy, right? Then here three dimensional Laplace equation, just an extension of this. It will be uxx plus uyy plus uzz is equal to 0. Okay, so these are the some standard applied partial differential equations. Now you note that in all these cases we have this c, right? So this c square we have taken means c must be a positive variable. So c is a positive constant, right? C is positive constant. We call it the propagation constant, right? Propagation constant. Sometimes we are asked to find what is the value of c such that a given equation will satisfy the one dimensional heat equation, one dimensional Laplace equation, sorry, two dimensional Laplace equation. There is no c, so that this given function satisfy the two dimensional Laplace equation, right? So for what value of c it will satisfy one dimensional wave equation, one dimensional heat equation, two dimensional wave equation, like that. Okay, so for short question point of view, let me discuss such examples. Now coming to one example, for what value of c, right? This u is equal to x square plus t square. Second, u is equal to sin ct sin x. Third, u is equal to sin at sin bx. For what value of c? Here it is for what value of c. Okay, the c is a positive constant. Note that c is a positive constant. The following will satisfy the one dimensional wave equations, right? So coming to the solution, we have one dimensional wave equation is utt is equal to c square uxx. Let it be my equation star. Now for one, right, for my one, let u is equal to x square plus t square. So what is my ux? Ux is 2x, uxx is 2, and what is my ut? Ut is 2t, and utt is my 2 from star. Now from star, here utt is 2 is equal to uxx is utt is 2 here, and uxx is 2 here, is c square uxx. C square into 2 means 2c square, right? So that means here c square is equal to 1. So this implies c is equal to 1. Okay, don't write plus and minus 1 because c is a positive constant. For c is equal to 1, this given 1 will be satisfy here one dimensional wave equation. Okay, likewise coming to the solution of 2, right? For your 2, for 2, what is your u? Here u is equal to sin ct sin x, right? So what is your ut is derivative of sin ct. You see, it is c cos ct, sin x is constant, and here utt again derivative of cos is minus sin, because of chain again one c will be multiplied, it is minus of c square sin ct, and sin x remains silent. Likewise, what is my ux? Sin ct is constant, sin x derivative is cos x, it is my sin ct cos x. Then what is my uxx? Derivative of cos x is minus sin x, so minus sin ct sin x. So now we'll substitute in my star. Now star follows. Now star follows. Right. Utt is my star. Star means what? Utt is c square uxx. Right. So what it follows? You substitute utt is, it is minus of c square sin ct sin x is equal to c square into uxx. So c square multiplied here and still a minus sign is there. Right. You see, sin ct sin x. So what happens here? Here left hand side is equal to right hand side, is not it? That means whatever c you choose, right, for any c, for whatever left hand side is right hand side. So what is the value of c? So this implies c is any arbitrary, right, and positive constant, and that constant must be a positive constant as per the definitions, right? Now coming to the third question, u is given this, so accordingly I find utt and I find uxx, my one dimensional wave equation. Just I substitute here, utt is minus s square sin 80 sin bx, and in the right hand side it is c square, so minus of b square c square sin 80 sin bx. So what is my c square? So that means my c square is my a square by b square, is not it? So what is my c? C is equal to a by b, right? So this is the value of c. Clear? Now likewise we have your one dimensional heat equation. Now coming to one more example, u is given this, right? We have to find the value of c and omega which will satisfy the one dimensional heat equations. Okay, so likewise we have one dimensional heat equation is ut is equal to c square uxx. Let it be my here double star, right? Let my u is equal to e to the power minus omega square c square t cos omega x, right? So we find ut, if you partially differentiate with respect to t, right, t, this is constant, so this, if this factor is multiplied with t, so by chain rule it will be multiplied here, so it will be minus of omega square c square e to the power minus omega square c square t cos omega t omega x remains silent. Similarly, what is my ux? Ux is only the differentiation of this cos omega x. Now it is my silent, e to the power minus omega square c square t is silent, cos omega x derivative is minus sin omega x, one omega will be multiplied, right? It is my minus omega, this omega will be multiplied by chain rule. What is my uxx? So uxx will be derivative of sin is cos, again one more omega, here omega minus omega square e to the power minus omega square c square t, it is here cos omega x, right? In view of star, now in view of star to set double star to satisfy we have ut means minus omega square c square e to the power minus omega square c square t cos omega x. In the right hand side it is c square, c square uxx means minus omega square c square e to the power minus omega square c square t cos omega x. So what will happen? Here left hand side is exactly same as the right hand side. So what is the value of c of omega? Right. So c is any arbitrary constant, means this constant must be a positive constant, and omega is any arbitrary constants, right? Omega is any arbitrary. For c it is better we should mention that it is positive, but omega is any arbitrary constant. Now in view of your Laplace equation, you can write it del square u is equal to 0, right? And also here you can write it, del square u is equal to 0. What is your del? Your del, inverted del or nabla, it is my del square by del x square, right? Plus del square by, so here in view of this, what is your del? Right, this del, inverted del or nabla, what we call del by del x, I del by del x plus j del by del y. And here we write del is equal to I del by del x plus j del by del y plus k del by del z. It is called the vector differential operator, right? Vector differential operator. Anyway, coming to one example in this point of view, you are given u is equal to arctan y by x. Verify that it will satisfy this two-dimensional Laplace equation, okay? So what is my u? So let my u is equal to arctan means tan inverse, right? Tan inverse y by x. So that means what is your ux? Tan inverse, it is 1 by 1 plus y square by x square. Sorry, it is again by chain rule derivative of y by x. So into minus y by x square, right? So accordingly we will find what is your uxx. If you simplify it, you will find 2xy divided by x square plus y square whole square, okay? So if you solve it, it is your minus y divided by x square plus y square. Accordingly what is your uy? If you differentiate it, it will be your x by x square plus y square, and you find uyy, it is minus 2xy by x square plus y square whole square. Now if you add these two, okay, uxx plus uyy is equal to 0. So that means del square u is equal to 0. So it satisfies the two-dimensional Laplace equations, okay? So likewise you should solve some more problems from your book. So now let us discuss the solution of PDEs as ODEs, right? We will now discuss solution of partial differential equations as ordinary differential equations. Now solution of partial differential equation and ODEs. Coming to some basic concepts. In view of ODE, suppose y is my y of x, and suppose here I am taking u is my u of xy, okay? So here if my dy by dx is equal to 0, right, then what will happen? So that means here dy is equal to 0 dx, right? If we integrate both sides, then what we are getting? Y is equal to, purely it is a constant, right? You mark the difference, So now if here you are given del y by del x is equal to 0, what does it mean? Right, what does it mean? Here del y is equal to 0 del x, right? So if you integrate both sides, what will happen? You think suppose you are given, this is u. So you think here suppose some u is equal to 5y plus 7. So what is my uy? Right, ux is my 0, because y is constant with respect to x, is not it? So this 5y is 7 is nothing but a function of, it is a function of y, right? So here we will write what? Here we write pure constant, but here we write, this implies my u will be a function of that constant, okay, that will involve y, means it is a function of y, or I write f of y, right, function of y. You mark this difference. Likewise, suppose you are given u y is equal to 0. So what does it means? Means here u is equal to, means del u is equal to here 0 del y. Now if you integrate both sides, means you will find here u is a constant. That constant will involve the other variable is x, or it may be a function of x, right? In that way we have to proceed different from your ODE. Likewise, suppose you are given integration of sin x del x, right? What you will write? Integration of sin x is minus cos x, okay, plus your integral constant is some c1. Since we are integrating with respect to x, this constant will involve y, means it is a function of y. So my intention is to say here, what is my integration of c1x del x? So this function of x is integrated to give you another function of x, let you call it c2x, plus the constant will involve the other variable, right? Means it will be a function of y. Clear? Similarly, if I ask what is your integration of c1y del x, right? Now this c1y is a function of y, is constant with respect to your x, so c1y remains silent here, right? Integration of del x is here x, plus we have the constant of integration is c2, it involves the other variable is y. So this basic concept will help you to solve some PDEs. Now you are asked to solve the following PDEs, simple PDEs, okay? So here if we think, let my u is of the form uxy, right? Two variables you say. In this line what will be the solution? Here uy is equal to 0. So that means here del u by del y is equal to 0. That means here del u is equal to 0 del y. Now if you integrate both sides, here u will be the constant, involve other variable, right? If I think that my u is a function of u x y z, right? So here uy is equal to 0 implies del u is equal to 0 del y. Now you integrate it, left hand side is u, in the right hand side the constants involve the other variables, means here x and z, okay, x and z. So this is what the difference, or I can write it is a function of x and z, okay. Now coming to your solution of 2, right? Question number 2. So solution 2, uxx is equal to 0. What does it mean? Del by del x of ux is equal to 0, twice the derivative of u. So that means here del ux is here 0 del x. If you integrate both sides, it will be here ux, and here it will be c1y, right? Now ux is my del u by del x, it is c1y del x. Now you integrate both sides, here it is u with respect to x, this is my constant, so this integration of del x is my x, it is my c1y, plus the other variable is my c2y, okay. So this is my answer here. Coming to the solution of 3, uxy is equal to 0. What does it mean? Del by del y of ux is equal to 0, right? Is not it? Or if other way you write del by del x of uy is equal to 0. So del ux is my 0 del y. I integrate, left hand side is my ux, right hand side is my c1x, okay. Then what is my del u? Del u is c1x del x. Now I integrate it. So here u is function of x integrated to give another function of x. Then the constant will involve the opposite variable, right? Opposite variable. So this is the answer, okay. Now let us solve few more examples. Now you are asked to solve this followings, okay. Coming to the solution number 1. So here uxy is equal to ux. So we write it del by del y of ux is equal to ux, okay. Just variable separation, del ux by ux is my del y only. I just bring this, okay. I just bring this. So here left hand side is ln ux, and in right hand side, if I integrate both the sides here, in the right hand side it will be my y is integrated to give you, del y is integrated to give you y, plus the constants will involve the other variable. So I may write it ln c1x to get a better answer, okay. So now if I bring it to this side, left hand side, so it is my ln ux by c1x is my y. So my ux by c1x is e to the power y. So what is my ux? Ux is my c1x e to the power y. Now I just again ux is my del u by del x, so del u is c1x e to the power y del x, right? So now if I integrate, this is my constant here, left hand side is my u and e to the power y is my constant. C1x is integrated to give you another function of x, so c2x plus the constant will involve the opposite variable. So this is the answer. Okay, now the solution of 2 and 3, these are non-homogeneous case. Okay, coming to solution number 2. So now coming to the solution 2, let me to remind you here, just to recall the corresponding ordinary differential equation. Suppose you have y double dash plus 5y dash plus 6y is 4e to the power 5x. Okay, then in my left hand side, the homogeneous solution is, it is my y double dash plus 5y dash plus 6y is equal to 0. So what is the auxiliary equation? Lambda square plus 5 lambda plus 6 is equal to 0. So what is my lambda? Is my minus 2 and minus 3. What is my y homogeneous? Is c1 e to the power minus 2x plus c2 e to the power minus 3x. Now for my y particular, what will happen? I will write it d square plus 5d plus 6 into y is 4e to the power 5x, right? So now what is my y? Y is 1 by d square plus 5d plus 6 e to the power 5x. Now I just replace d by my 5, so it is by 1 by 25 plus 25 plus 6 e to the power 5x, e to the power 4 is there, that 4 e to the power, right, 4 e to the power 5x. Clear? So I can write it. So this is my y particular is my 4 by 56 e to the power 5x. Then what is your y? Y is your y homogeneous plus y particular. Y will be y homogeneous plus y particular. This is equal to c1 e to the power minus 2x plus c2 e to the power minus 3x plus 4 by 56 e to the power 5x. So this is the corresponding, right, where y is a function of x only, right, the corresponding ODE. So this here it is the same thing, right, here it is the same thing. What is your homogeneous solution? Your homogeneous solution is uyy plus 5uy plus 6 is equal to 0. What is your auxiliary equation? Is your lambda square plus 5 lambda plus 6 is equal to 0. So that means my lambda plus 2 into lambda plus 3 is equal to 0, middle term factorization. So my lambda is equal to minus 2 and minus 3. So here u homogeneous will be, you see, this c1 will involve here, c1 is a function of, right, since here y is there, right, it is e to the power minus 2y plus c2 e to the power minus 3y, but this c1 will be a function of x here, opposite variable, okay, function of x here. So this is the difference, this is my u homogeneous. Then what will happen to my u particular? Your particular solution, in particular solution you can write it d square plus 5d plus 6, d is a function of y here, okay, and this u will be my 4 e to the power 5x. So what will happen? So that means my u is, right, 4 by dy square plus 5 dy plus 6, it is my y, e to the power 5y. Now my dy is just replaced by 5, so this is equal to 4 by 25 plus 5 into 5 plus 6, it is e to the power 5y. So this is your 4 by 56 e to the power 5y. So therefore the general solution u is u homogeneous plus u particular. So this is equal to here c1x e to the power minus 2y plus c2x e to the power minus 3y plus 4 by 56 e to the power 5y. So this is my answer. Now coming to 4. you have, if I just make its corresponding ordinary equations, then it will be my x square y double dash minus 2xy dash plus 2xy dash minus 2y is equal to 0, right? So what is the auxiliary equation? The auxiliary equation is m square plus a minus 1, means 2 minus 1m minus here 2 equal to 0. So it is my m square plus m minus 2 equal to 0. Now you apply the middle term factorization. It is m square plus 2m minus m minus 2 is equal to 0. m into m plus 2 minus 1 into m plus 2 equal to 0. So that means m minus 1 into m plus 2 equal to 0. So what is your m? m is your 1 and minus 2. So what is your y? y is c1 x to the power 1 plus c2 x to the power minus 2. So this is the case. So likewise, so what will be the solution of this? We have here auxiliary equation. Auxiliary equation is here m square plus 2 minus 1m minus 2 is equal to 0. So if you simplify, here m is equal to 1 and minus 2. So therefore here u will be c1 e to the power c1 x to the power 1 plus c2 x to the power minus 2. But since this is ux here, the variable, opposite variable will be involved here, right? Opposite variable will be involved here. So this will be c1yx, right? x c1y plus c2y x square c2y. We may write it a function of, we may write it x phi of y plus this x to the power minus 2 plus x to the power minus 2 psi of y. So this is my answer. Okay, so this is my answer. Next we have to solve this system of PDEs. Simultaneously we have to solve these two. We have to solve this and simultaneously we have to solve this 3. These are the system, right? System of PDEs, right? So coming to the solution of 1, ux is equal to 0 and uy is equal to 0. Two equations, right? This is my 1 and this is my 2. We have to solve this simultaneously. So we start from any one. Let ux is equal to 0. What does it mean? Means del u by del x is equal to 0. So that means my del u is equal to my 0 del x. So integrate both sides. So u is equal to my c1y, right? So now you think the viewpoint of ui. Now if my u is equal to, right, here 2x square plus 5x plus 7, right? Then what is your ui? Here ui will be 0. Then that means this u here is a function of, this u here is a function of, right? U here is a function of here x, right? U here is a function of x. Now if I separate this, right, this is my c1x and this is my c2y. So what is my c2y? c2y is 7, means it is a pure constant, okay, right? If I write u is equal to c1x plus k, then what will happen here? Here ui is equal to 0 here, right? So what will happen to this c2y terms? If I write c2y, then c2y is my constant, okay? So this c2y is my constant only. In view of this, u is equal to k. So therefore u is equal to k only, okay? If I solve one more example, then your idea will clear. So coming to, suppose here solution 3 say. So let I start from this middle one, okay? Then the constant will be taken from this and the constant will be taken from this, okay? So let here uxy is equal to 0. Let uxy is equal to 0. So what does it mean? Here del by del x of ui is equal to 0. So del ui is my 0 del x, okay? Now I integrate both sides. ui is equal to my c1y. So now if I integrate again, del u is equal to c1y del y, and I integrate. So what is my u? U is equal to my function of y integrated to give another function of y, plus the constant will involve the opposite variable. So u is my this. So now this c2x will be collected from, right? c2x will be, what are the two more equations? The two more equations is uxx is equal to 0 and one more equation is uyy is equal to 0, right? So here uxx is equal to 0 will give you, it is integrating with respect to y means it is a function of x, it is a function of x. So here c3x will be taken from this only, uxx is equal to 0, right? uxx is equal to 0, so this will give you this, and here uyy is equal to 0, this will give you this, this will give you this. So what is my c2y? If uyy is equal to 0, if I think that u is a function of your c1x plus c2y, right? Since uyy is equal to 0, so c1x is anything, but c2y has to be a fast linear equation only, ay plus b. Okay, so in view of this, your c2y will be your ay plus b. Now in view of this, okay, in view of this, here u may be a function of y is anything, but the function of x, okay, so the function of y may be anything, but the function of x must be linear, so that the second derivative will be 0. So it will be your cx plus d, right? Cx plus d. So from this viewpoint, what you can substitute? You can substitute this will be my cx plus d, cx plus d. So now if I combine these two, then what is my u? So that means my u is equal to b plus d will give you another constant here. It is ay plus cx plus b plus d, let it be my k, is my k. So this is the case, okay. So that means we solve this middle one, right, and the constant will be collected via this and this, right? So this is a solution of system of equations. Similarly, coming to the last one, solution 2. Let I start, so what is given? uxx is equal to 0 and uyy is equal to 0. Simultaneously we have to solve 1, 2, right? So if I start from this, let my uxx is equal to 0. So that means del by del x of ux is equal to 0. So that means my del ux is equal to my 0 del x, okay. If I integrate both sides, ux is equal to c1y, then my what is my del u? Del u is my c1y del x, okay. Now I integrate both sides, so my u is equal to x c1y. Since this is del x, the constant will involve the opposite variable, okay. So now this c1y and c2y will be collected from this only, okay. Now from this viewpoint of this uyy, if my u is suppose anything in terms of x, okay, c1x plus c2y. Now c1x is anything. Now this c2y must be linear in y, ay plus b. Then only here uyy is equal to 0. Then only here uyy is equal to 0. So what will happen to c1y? So it must be a linear equation, right, in y. So I can write it. It must be my x. This is a linear equation in y, ay plus b, and this must be a linear equation in y, right? I can write suppose cy plus d. Then I just add it. It is my axy plus bx plus cy plus d, okay. So this is my answer, okay. If you start from the answer side, if you differentiate it twice with respect to x, it will also 0. If you differentiate it twice with respect to y, it will also 0. Now coming to the final summary of this lecture. So here we knew what is the definition of PDE, right? Then example of applied PDE, right? Applied PDE we knew. Then verify C, for what value of C. Then we discussed solution of ODE, PDEs as ODEs. Then we discuss the simultaneous PDEs, right, system of PDEs, right. That's why the video is getting lengthy. We should close it here. Now if you feel this lecture is useful and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. Let us close this lecture. Thank you all. Have a nice day.